Hello. In this video, I want to go over some of those statistics problems that we just finished covering in this unit. So if you're ready, grab your notes, a pencil and paper. Let's get started. So the first question I want to remind you of is the different types of sampling techniques that we studied in this module. So if you have a question that says, you have a sample that contains a random selection of groups or units, what kind of sample is this? Okay, random selection of groups or units. The key is it's a random selection and you're choosing groups or units that are already in nice little organized groups or units. This is called a cluster sample. Okay, so we talked about various types of sampling, stratified sampling, random sampling. We did systemic sampling, cluster sampling. So there are different types and you want to be comfortable with all of those different types. Okay, so make sure you have those in your notes and you're ready to differentiate between the two. Of course, the random is the best one for real statistical analyses, but it is important to recognize if you hear about a different type of sample, what was the sampling technique that they used. All right, let's head to our next slide. If you're given a set of data, can you use that data to create or construct a frequency distribution? And in this case, we're giving you data that is ages of people. So we've given you 40 ages of people here. These are people who apparently attended a symphony at some point in their lives. And they've told you that they would like the first class of this frequency distribution to be from age 20 to 30 inclusively. That's implied. Okay, so remember how we begin a frequency distribution. So we have basically two columns here. Okay, so the first column represents the name of the classes. Usually I just write classes, but you could say these are ages in parentheses. And then the second column is the frequency. So how many people are in each of these classes? Okay, you could say number of people in each class. That means the same thing here. Now, because they gave me the first class, they gave me a nice starting place. So they've told me my first class is ages 20 to 30 inclusively. So with that piece of information, I can deduce, so I can think a little bit, what we call the class width would be. So what must the class width be if the first class is inclusively 20 to 30? Now, sometimes you're tempted to do 30 minus 20 and get the answer of 10, but it's always going to be one more than that number, that difference, and that's because you have to include 20 itself. So if you have your finger, you could do 20, 21, 22, 23, you could add them up on your fingers, and you would notice there's actually 11 numbers represented, ages 20 through 30. There aren't just 10. If it had been 21-year-olds through 30-year-olds, that would just be 10 people there, 10 types of ages for people. So the class width is actually 11. So once you determine that that's your class width, you could then figure out what the next class should be. It would have to start at the next number, which is 31, and contain 11 more. So notice here, 31 minus 20, that is 11. So again here, we should have something minus 30 that gives me 11, and that would be 41. 41 minus 30 gives me 11, right? So this is, again, my next class. And I would continue doing this. My next class would start at 42, and it would go until, that's right, 52. So what some students do is they'll add 11 to 20 to get 31. They'll add 11 to 31 to get 42, and they continue from there. Okay, so the next class would be adding 11 to 42, you're at 53, and adding 11 to 50, and adding 11 from there, where are we at? That would be 63. That's right. And so we continue to our next class, and we get 64 to 74. Now I'm going to stop there. Can you figure out why I'm stopping there? Why did I stop there? Just move those arrows for a moment. Why? Because I only have to include a class for the highest value that is present. So if you did a quick scan of all of the values here, what is your highest value that you see? Do you see anybody in the 70s? First of all, do you see anybody in the 80s? I don't see anybody in their 80s that went to the symphony. It doesn't mean that there aren't people in their 80s who go to the symphony, but in this particular sample, there weren't any people in their 80s or 90s or hundreds. It looks like the most elderly person here was 72, right? So the class that goes up to 74 would include them, so that is sufficient. So the next thing I would notice is to check if your data has been pre-sorted for you. If it has, it's going to make your life a lot easier. Otherwise, you're going to have to do a lot of visually scanning and maybe ticking off each one that you've already talked about. So for example, 20 to 30-year-olds, let's see how many of those there are. We have a 20-year-old here, so that's 1. We have a 26-year-old, that's 2. 31 would be not in this class, that'd be the next class. Who else do we have? We would have 39, that's too high. Hey, there's another 20-year-old, there's 3. A 29-year-old, there's 4. 31 would be too big for this class. We keep going in our second row. I'm looking where I should stop. How about 23? That would be in this class. So far we're at 5. Nothing else in that row. In the third row, I have a 23-year-old, so that's my 6th one. And then I go looking around, I see there's a 26-year-old, so there's my 7th one. And then I would see a 30-year-old, that works. There's my 8th one. Anybody else? 20 to 30. Did I miss anybody? So let's keep looking. So far I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I missed a 30-year-old here. So let's count them up now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There I have them all. Okay, so I had that class complete. Let's pick another color for our next class. How about brown? Okay, for our next class of 31 to 41-year-olds, I see a 31-year-old, there's 1. A 34-year-old, there's 2. A 39-year-old, there's 3. Another 31-year-old, there's 4. A 35-year-old, there's 6. And a 40-year-old would count, so there's 7. And there's 32-year-olds, there's my 8th one. A 35-year-old, there's my 9th one. A 40-year-old, there's my 10th one. Third row, anybody? Ah, there's a 30-year-old. That technically should have been in my last one. Oh, I missed one. So let's put him in there. He is blue, so we'll have to come back and think about him in a moment. And make sure I added correctly, because you never know. You got to watch yourself. Okay. Continuing on with my brown colors here. Here we go. There is a 33-year-old here. There is a 37-year-old here. There's a 40-year-old there. And what else do we have here? We have a 34-year-old, a 38-year-old, and that would be it. So when I add those up, all my browns, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm getting 14. And let me add up my blues again, make sure I really have a 10, or if I have 11. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 should be the correct answer there. So I apologize for that typo. That was 11. Let's get my blue color out. Okay, so we should have 11 so far for the first class, 14 for the second class. Let's pick another color for our third class. How about yellow? So for the next class, we're looking for 42-year-olds to 52-year-olds. So that would be the 45-year-old, that would be the 50-year-old, that would be this 49-year-old, this 47-year-old, and 51 would be included, that would count. And who else would count? This 49-year-old here, and this 49 and this 42. When I add the number of yellow circles, I get 1, 2, 3, 4, 5, 6, 7, 8. That's what I'm getting there, 8. All right. So hopefully we didn't make a mistake on that one. Let's go to our next one. Next color, let's do maybe red for 53 to 63. So 53 to 63, there's a 62-year-old. I guess I'm using orange, I said red. 62-year-old for that category. And what else? We got a 63-year-old, that counts. And it looks like, oh, we did miss a yellow one. See, you can see my humanity coming out here. There is a 51, so we're gonna go back and make that 9. Okay, so let's grab my orange color. Okay, and let's continue. We're looking for 53 to 63 here. What else do we have? 53 to 63. 66 doesn't count. 54 counts, and 57 counts. So let's see how many oranges we've found. 1, 2, 3, and 4. That's what I had originally. Good, that makes more sense. And finally, let's look at our last category. We think this is red this time. Here we go. 64 to 74. Do we have anybody? Well, first 2 rows, I don't see anyone right away. Third row, I see a 69 and a 66, and then I see this 72. Oh, now I see what happened in the first case. Okay, I had circled 72 in blue when I was talking about something else. That makes more sense. All right, so that's a red one. So there's 1, 2, 3 total for that class, which means the real answer for blue was 10, but for a different reason than before. So that one is 10, but because I had circled it earlier in my problem without catching that. So this is actually still 10. All right, so when you actually calculate this, you should have, in the very end, I apologize for any confusion, 10 people who were between the ages of 20 and 30, 14 people between the ages of 31 and 41, 9 people between the ages of 42 and 52, 4 people between the ages of 53 and 63, and 3 people between the ages of 64 and 74. Now keep in mind that would be the answer if they just asked you for a frequency distribution. But what we can do with that, remember from our module of many videos on statistics here, we talked about creating what we call a frequency polygon, a histogram, a circle graph, right? We also talked about a stem and leaf plot, which would not require a frequency distribution, but we could also use that to describe this data set. So what I would encourage you to do is go an extra step in this question if you have time and create each of those and make sure you really understand how to do that, okay? When you're ready, let's head over to our third example. This one says we have a person named Stephanie, and Stephanie has collected daily tips for 1 week of $51 on the first day, $70 on the second day, $54 on the third day, $28 on the fourth day, $105 on the fifth day, maybe that was Friday night, $64 on the next day, and then $83 on the last day. We were asked to find the mean, median, mode, and mid-range. Remember what those are called? Measures of essential tendency. So feel free to go back to that video if you have any questions about what those mean, okay? So for the mean, no pun intended, what we mean is that is the average, and we sometimes refer to that as X bar for our sample mean. Okay, and the way we did that was we added up all of the data points and divided by n. So that's symbolically is the sum of all X values, all data points, divided by the number of items, your sample size. In this case, that would be 51 plus 70 plus 54 plus 28, add 105, add 64, and add 83. And when you add those up, we have to divide by the number of them, and these were the different days of the 7 days of a week, so it's dividing by 7 different numbers there. We should be getting our total of 455 divided by 7, or her average tip each day was $65. That's what the average means, right? On average, she was earning $65 in tips each day. Okay, so once we found the mean, do we remember how to find the median? What did we have to do to find the median? How do we find the median? To find the median, we need the middle number. So what's the first step always got to be? That's right. To find the median, you have to sort from low to high. So her lowest tip that she received was a $28 tip. Then a $51 tip. Then $54 tip. Then the $64 tip. Then the $70 tip. Then the $83 tip. And finally, the big tip, the $105 tip. So make sure I have them all. 1, 2, 3, 4, 5, 6, 7. Yes. Now remember for median, once you've done the hard work of sorting, and again, this wasn't that bad, just 7 data values, but typically if you have a large data set, you'd want to use some technology, whether it's Microsoft Excel or a TI calculator of some type. Okay, so once you've done the sorting, the next thing to do is to recognize, do I have an even or an odd n? Is my sample size even or odd? Well, the n is 7, which is odd, so this is actually quite easy. We basically say you go half of that number, which is 3, and then there's change. So you go 1, 2, 3, stop, and then 1, 2, 3 after. So you have a clear middle number, right in the middle, okay? So 64 must be my middle number. So my median is 64, exactly. So her median tip, the tip right in the middle of her data, was that $64 tip. But remember, sometimes there's a little more work to finding the median. If there were 8 days here, you would have had to find the 2 that were closest to the middle and take their average, okay? That would have been the median. So we have the mean, we have the median. How do we find the mode? Do you remember? The mode was the most common or the most frequent tip. And sometimes there is no mode if there was no repetition of any values. And in this case, again, if you look at when I sorted, there was no number that appeared twice or 3 times or 4 times. They all appeared only 1 time. So we would say there is no mode, or none would be my answer there. Finally, how do you find the mid-range? Do you remember that? How do you find the mid-range of a data set? Well, to find the estimate of what's happening in the middle, you basically look at the extremes, and that's what the word range is implying, right? So range typically means the spread of values. So when you're looking at the spread, you would look at your lowest value and your highest value, but we're not finding the range. That's a measure of dispersion. We're looking for the mid-range, an estimate of what's happening in the middle by just looking at those last 2 extremes. So what we did for the mid-range, if you recall, was we took the lowest plus the highest value and divide by 2. Take the average of the extremes. And when we do that, we get 28 plus 105, whatever that sum is, divided by 2. That's 133 divided by 2, so her mid-range tip would be 66.50 each day. Okay, notice those numbers are all pretty close to each other, so this is pretty close to what we call a normal distribution, where the mean, the median, and the mode would all be the same. But in this case, we did not have a mode at all. So keep that in mind. Make sure you know how to find each of these measures of central tendency, and you can also, of course, use technology when you have a bigger data set, but it is important to understand conceptually why we would depend on a median in most cases instead of a mean, and what a mean means, and vice versa. Okay, let's head over to question 4 if you're ready. Speaking of measures, these are the measures of dispersion that we talked about in this unit. We're asked to find the range and the standard deviation for the caffeine measured in milligrams of these 9 selected soft drinks. So to find the range of your data set, we kind of reviewed that in our last example. What did we do for range? That's right, we just took the extremes and we subtracted them. So the range is just your high minus your low. So in this case, I haven't sorted my data out, but my highest value does appear to be what number? That's right, 80. And what does my lowest value appear to be? 25. So here's my high and here's my low. So 80 minus 25, I have a range or a spread of 55 milligrams of caffeine. So my lowest caffeinated drink would only have 25 milligrams. My highest caffeinated drink has 80 milligrams. So I have a spread of 55 milligrams for my caffeinated beverages. Now to find the standard deviation, that's going to take a lot more work if we're doing this by hand. So remember that the standard deviation formula for a sample was the big square root of what? Of the sum of parentheses, your x values, each data value, subtract the mean, the sample mean x bar, take the sum of those and the sum of those that are squared. Now they had to be squared because we're talking about negative and positive numbers, and we don't want them to wipe each other out when we add them up. Divided by 1 less than your n value. And this is because we sometimes have a small sample that might not be representative of a larger population. Okay, so we have this formula, and the very first step we did, remember in your steps for standard deviation, which is what we're working on right now, was you have to find x bar. You have to find the mean. In order to do that, remember back to our last example, you add up all your data values and divide by n. What is n here? N is 9, right? So there's n. N is 9. There are 9 different data values. So we would add up 37, 43, 25, 80, 55, 33, 40, 30, 35. Go ahead and add them up. Pause the video if you need to. In fact, I would encourage you to try the whole problem on your own and then come back and see if you did it the same way. So when you do it, what did you get? 378 is what I got, divided by 9. And that gave me the answer 42. Okay, so that was my first step. Why do I need that? Well, I need that so that I can now find the difference between every data value and that number. And the way we recommended doing that is to make a column for each of your data values, x. So we have 37, 43, 25, 80, 55, 33, 40, 30, and 35. Okay, so you have a column for each of your x values. And then we want to find the difference between each of those x values and x bar. So x minus x bar. So when I do that carefully, I'm going to take 37, in this case, minus 42. And when I do that, I'm getting negative 5. Now, what I'm going to be doing in the next step, if you can think ahead, is I'll be squaring it, but we'll get that in a second. Then I'm going to do 43 minus 42, and I get positive 1. I'm going to do 25 minus 42, and I'm going to get negative 17. I'm going to do 80 minus 42, which gives me 38, positive 38. I'm going to take 55 minus 42, and that's going to give me positive 13. I'm going to take 33 minus 42, and that gives me my negative 9. I'm going to take positive 40 minus 42, which of course is negative 2. I'm going to take 30 minus 42, which of course is negative 12. And I'm going to take 35 minus 42, which of course is negative 7. Okay, once you've found each of those differences, you need to square them, because if you don't square them, if you were to add them up right now, some of them would cancel each other out. So let's go to this next step of squaring those differences. So to square those differences, we have to actually take each of them and multiply it by itself. So basically the whole purpose is to turn them all positive. That's the purpose of this step. So if we square each of these values, let's see what we get. We would get positive 25. 1 times 1 is 1. Negative 17 times negative 17 is positive 289. Positive 38 times positive 38, that's a big number. It's positive 1,444. Again, 13 times 13 is positive 169. Negative 9 times negative 9 is positive 81. Negative 2 times negative 2 is positive 4. Negative 12 times negative 12 is positive 144. And negative 7 times negative 7, did you get positive 49? I hope so. Okay, now if you, for some reason, you were using your calculator, let's say, and you got a negative answer for one of these, I know what they did, or I know what you did. You might have forgotten to use parentheses because your calculator only is as good as the person entering the number in. Sorry. So if you don't put that parenthesis, it thinks you want the opposite of the answer. That's why they're giving you a negative in the end. So make sure you put parentheses around the negative number in order to get the positive result here. Okay, so once we have that, we are ready for the next step, which was add them up. That's what that sum is. So this was our fourth step, if you will. So if I add them up, what is the sum of all of those values when I add them up? Well, I take 25 plus 1 plus 289 plus 1,444 plus 169 plus 81 plus 4 plus 144 plus 49. What did you get? That's right, I got 2,206. Okay. Once you've done that in the formula, look what comes next. You now need to divide that number by 1 fewer than n. N was 9. So what am I dividing that by? I'm dividing it by, that's right, 8. So now I need to divide that number by 8 because n minus 1 is 8 if n is 9, okay? So 2206 divided by 8, you're going to get an answer. Now sometimes, if you're lucky, like this time, you're going to get an answer that stops, 275.75. But many times you're going to get an answer where the decimal continues on and on and on and on and on. The number continues after the decimal place. In that case, you do not want to just cut it off arbitrarily. That's called making a rounding error because you're rounding too soon. So what I'd like you to do is get in the habit of getting the answer that you have on the screen and then just hitting the square root button on top of it. Okay? So take the square root of whatever you have on the screen. Don't go ahead and stop and cut the number off and then take the square root of that new number. That will get you the wrong answer. So if you take the square root of whatever this answer is, so that's what we're going to do next. Make it another color. Oops, I lost it all. Well, if you take the square root of that number, let me write what I had so far. What I had at this step was the following. I had 2206, I think I was. If I said 08, I apologize. 2206, and we're dividing by 8. Now you're going to take the square root of that number, and you should be getting the final answer of 16.61. Okay? This is our sample standard deviation of the data. Okay? So if you think back to what you had earlier, you have it in your notes, even though it's not on my screen, the range was 55. That was a very big spread. The standard deviation here was 16.61, which we rounded to 2 decimal places, always 2 more than your data. This is telling us that on average, each data value is roughly between 16 and 17, right? 16.61 is roughly, let's say 17, roughly 17 points away from the mean. Remember what the mean was? We had found it earlier in the problem. The mean was 42. So on average, each data value is roughly 17 points away from that number. That's what this means. And if you're doing something where you are wanting to go ahead and see how close the data is, the smaller the standard deviation, the more likelihood that most of those numbers are near the mean. The bigger the standard deviation, the more spread apart these numbers are. And we kind of got a feel for that with that big range of 55. Okay, once you think you have that down, it's a long process, but once you think you have it down, head over with me to example 5. It says, for a normal distribution, what percentage lies within 2 standard deviations of the mean? Okay, so this is more, again, like the first question today. This is more of a concept question. Can you remember, or do you have it in your notes properly, what happens when we have a normal distribution? Well, a normal distribution means a few things. It means that the data, if you were to visualize the data from a histogram, it would actually turn into a bell-shaped curve for the frequencies. Okay, so the highest part is where most of your data would be. Most of your data would happen in the center here, okay? And we know that the mean, or the average for the sample in this case, is in the middle, and so is the mode, the most frequent, and the median, the middle. For a normal distribution, those three are the same. And we also were told that statistically speaking, if you go out one standard deviation, so if you add plus one standard deviation, let's use S for standard deviation, or if you go out negative one standard deviation, that total would be 68% of all of your values. So that percentage for this area here is 68%. Okay, so we learned that. But we said that if we went out two standard deviations, so another standard deviation, so plus 2s or minus 2s, that total of all of the data is going to be 95%. So if I were to take this piece here, add it to 68, and add it to this, all of this together from here to there should be 95% of all of your data. So 95% of all of your data lies within two standard deviations of the mean. That is the answer that they're looking for, okay? But make sure you have it in your notes that if you have within one standard deviation, 68%, within two standard deviations, 95%, and in fact, if you went out three standard deviations, do you have that in your notes as well? I hope so. If you go out three standard deviations in either direction, so that's this piece plus the blue and the red that we already talked about, that total amount of data that you're talking about represents 99.7% of all data values lie within three standard deviations of the mean. So you want to make sure that you have this in your notes, okay? You have this in your notes. This is your empirical rule. Okay, once you have it down and you think you understand that, let's head over to our next example. So this is when we were starting to review, for those of you who are going to take statistics, you'll be studying something called linear regression, and we needed to review what the slope of a line was and how to graph a line and look at the equation of a line. So let's take a look at finding the slope between two given points. Now you could visualize this, of course, if you had your x and y axis, your Cartesian coordinate system here. You could say, well, negative 3, 2, that would be 3 to the left of the origin and 2 above. So that would be in quadrant 2, we would say, because it's quadrant 1, 2, 3, 4. Okay, and that would be the point negative 3, comma 2. And 4, 8 would be 4 to the right of the origin and 8 above. So 1, 2, 3, 4, 5, 6, 7, 8. Getting a little high up there. Ooh, that's rough. Okay, so that's 8 and that's 4. So 4, 8, let's say, is somewhere up here in quadrant 1. So we can see that the slope between these 2 points should be positive, right? We are increasing from negative 3, 2 to positive 4, 8. And we could actually get that visually by saying, what is the rise and what is the run? If I were to go up, how much would I have to go up before I turn to the right and make a run for it? Okay, so we could do rise over run. That's one way of finding the slope. Remember, m comes from the Latin montere, and that's what we use for slope. And that would be your rise over your run. So if you wanted to do this visually, you could say, well, I'm starting at a y value of 2, and I'm rising to a y value of 8. So how much distance is that? What we call that the delta? What is the change there? Well, that's 6 above. So I rose 6 units up. So because I went up, I'm going to use positive 6, okay? And for my run, that's my horizontal movement. I started out at negative 3 on the x-axis, and I stopped at positive 4 on the x-axis. How much movement to the right did I go? That's right, 3 plus 4 is 7. So to the right, it's 7. So I'm going to say my slope here is positive 6 over 7. Now, you could have also done it differently. You could have said, I'm going to start at 4, 8, and I'm going to go down 6 units, that's negative 6, and left 7 units, and that would be negative 7. Negative 6 over negative 7 still gives you a positive 6, 7. So the answer should still be 6 over 7, and it's a positive slope indicating that we are increasing from left to right. Also note here, if you did not want to visualize this at all, if you're like, why did she just do all of this? I have a formula. Yes, you do. It's the change in your elevation, change in y, over the change in your horizontal movement, change in x. In other words, y2 minus y1, this is the one you remember, I hope, over x2 minus x1. And so this would be 8 minus 2. Those are the change in your y values. This is y1, y2 if you label them as such. And then x2 would be 4, and x1 would be negative 3. Now, the mistake most students make, and that's honestly the reason why I don't always encourage everyone to just use a formula, because a lot of students make little mistakes. We're human, okay? Is that they honestly, sometimes they forget that this is a double negative, right? And this becomes a positive 3, which means this is a positive 7, So 4 plus 3 equals positive 7. So a lot of students end up giving me is 1 in the denominator, and that is incorrect here because they take 4 minus 3 instead of 4 minus negative 3. So keep in mind I'm getting 6 over 7, the same answer, as long as I use the formula correctly. So if you think you're someone who might make a mistake with the formula, either 1, work on not making mistakes, or 2, maybe do it the visual way. Okay, once you understand slope, the basic idea of how to find slope between 2 points, make sure that you also understand how it works in the equation of a line. So let's head over to our last example. Suppose that there is a line of best fit that's been given to us, and you'll study this in statistics, for weekly revenue measured in dollars for a certain business that sells X items, so X is the number of items it sells, per week. And they found the equation to be Y, which is your revenue, equals 15 times X, which is the number of items you sell, minus 3,000. Use this equation to answer the questions below. What is the price per item? B is, what are the fixed weekly overhead costs for the business? C, what will the weekly revenue be if they were to sell 500 items per week? Okay, so again, if you have access to technology like Desmos.com, it's a great free graphing tool or a graphing calculator, you can simply type it in, you can visualize what's going on. But hopefully you also can understand, and you'll remember this going into either algebra or statistics next semester, that y equals mx plus b is what we call the slope-intercept form of a line, where m is your slope, it's the coefficient, the number in front, of x, and b is your y-intercept, because when x equals 0, y would equal that number. Okay, so what we notice here is we have a variable piece and we have a fixed piece. We're starting off at negative 3,000. So if I'm a business, I'm starting off in the red, if you will. Every week I owe $3,000. Why is that? Maybe I have to pay rent, right? Maybe I have to pay a fixed price salary to my employees, right? Maybe I have utilities to pay. So those are some fixed expenses that we have to subtract right off the bat. So if you were looking at a graph, you're starting in the red. And then you're going to increase the amount of revenue coming in by multiplying by 15 each time you sell an item. So what does that mean? Well, that means we know the price per item, don't we? It's going to be your slope. It's going to be m equals $15. For every item that I sell, revenue is coming in, okay? That's the revenue coming in here. Now, as far as what are the fixed weekly overhead costs for the business, that would be the deficit we're starting out with. That would be that fixed $3,000 that we're subtracting. So $3,000 would be the cost. And again, because it's a cost, that's why it's negative here, whereas revenue is positive. Money coming in is positive, money going out is negative. What will the weekly revenue be if they were to sell 500 items per week? Well, that's the beauty of a model, right? You could plug in the known piece and solve for the unknown piece. So a model is good for making predictions, and if it's a good model, it's going to be pretty accurate, and if it's a bad model, it's not worth anything, okay? So that's very important to understand if your model is good or not, and you'll learn that more if you take a statistics class. All right, so let's take a look. If this model is correct, this would mean that y equals 15 times 500, if that's the number of items you sell that week, minus 3,000. So when you do this, you're going to get 15 times 500, or 7,500, is the amount of money coming in, but then we have to subtract our overhead, $3,000 for the week. So how much do we actually call our real revenue in the end after we've taken away our overhead? Just 4,500. Okay, so that would be our answer here. But again, we can make predictions based on one of those knowns. If we have the x, we can solve for the y. If we have the y, we can solve for the x. So if you know you want to make a revenue of $10,000 a week, we could then plug in 10,000 for y, solve for x, and we figure out exactly what we should be aiming for the number of items to sell every week. So I hope that makes some more sense for you. So once again, in this video, we've now talked about all of the different ways that you can use statistics in real life, and also basically you're going to need to know each of these different types of situations: frequency distributions. Do you understand measures of central tendency, measures of dispersion? Do you understand the basics of slopes and lines? If you do, you're going to be in good shape not only for this test, but for future math classes like statistics as well. Well, if you have any questions, please reach out to me by email. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.